Hey everyone, welcome back for another deep dive. Today we'll be exploring the fascinating world of software testing order.
Ooh, yeah.
Why is it so important, and how does it impact the quality of the software we use every day?
Right. And
Yeah.
you know what? It's kind of like building a house. You wouldn't paint the walls before you've even laid the foundation.
Oh, definitely not. That's a great analogy. You'd end up with a real mess.
Exactly. And that's what we want to avoid in software development. So we'll uncover the stages of testing.
Okay, I like it. We're laying the foundation.
Yes. And we'll see how each one builds on the previous one to create a really solid structure.
So no shortcuts?
Nope, no shortcuts. We'll even share some real-world examples and maybe even a few testing horror stories.
Oh, I love a good horror story.
I've got plenty.
Okay, so let's get started. We hear a lot about test cases in software development. But for those who are new to this, can you explain what exactly a test case is?
Sure. So imagine a test case as a detailed recipe for testing a specific function of your software. Okay, like step-by-step instructions.
Exactly. It outlines the ingredients, the steps, and even the expected outcome, like a recipe for success.
That's a great way to put it.
It helps ensure that everyone's on the same page and that we're testing things consistently.
So no matter who's following the recipe, they'll get the same result.
Precisely. It's all about precision and repeatability in testing.
Okay, so we've got our recipes. Our test case is ready.
Right.
Let's talk about the first stage of testing. Unit testing.
Ah, yes. Unit testing. This is where we zoom in on the smallest parts of our software.
The building blocks.
Exactly. Think of it like testing each individual light bulb before wiring them into a whole lighting system.
So we're making sure each unit works perfectly on its own before we start connecting them together.
Yes. And in unit testing, we're really focused on isolating those units, testing their logic, and making sure they're robust.
So if we're building, say, an e-commerce site, we'd test something like the function that calculates the total price of an order.
Exactly. We'd feed it different inputs like item prices, quantities, discount codes, you name it.
And make sure it spits out the correct total every time.
Exactly. And we'd test edge cases too. Yeah.
Like what happens if someone enters a negative quantity or an invalid discount code?
Right. We want to make sure it handles all those weird scenarios gracefully.
So unit testing is all about those little details, making sure each component is rock solid before we move on.
Yeah. It's the foundation of our testing process. Remember, unit tests, check the smallest part first.
Okay, got it. So once we're confident in our individual units, what's next?
Well, then we move on to integration testing.
Integration testing. Okay, so now we're starting to connect those individual units.
Exactly. This is where we see if all those pieces can actually work together. Like when you wire all those light bulbs together, you got to make sure the whole circuit works.
Right, and that none of the wires are crossed.
Exactly. Integration testing is about making sure the data flows correctly between different parts of the software, that they can talk to each other, and that they work harmoniously.
So going back to our e-commerce example, we test things like the interaction between the shopping cart and the payment gateway.
Exactly. We want to make sure that when someone clicks checkout, all the information is sent securely to the payment system, that the payment is processed correctly, and that the order is confirmed.
It sounds like things can get pretty complex at this stage.
They can. You're dealing with multiple components, potentially built by different teams.
And you need to make sure they all speak the same language.
Right. But that's why integration testing is so crucial. You catch those integration issues early on before they become major headaches. Just remember, integration tests, check if the parts talk to each other.
Okay. That's a good one. So we've tested our units, we've checked the connections. Where do we go from here?
Well, from there, we move on to the big picture. System testing.
System testing. So now we're looking at the entire application as a whole.
Precisely. This is where we put on our user hats and really try to use the software like a real person would.
So we're not just testing individual functions anymore.
Nope. We're walking through entire user scenarios, like placing an order, creating an account, or whatever the software is designed to do.
So if we're testing a ride-sharing app,
right,
we actually go through the whole process of requesting a ride, tracking the driver, making the payment, everything.
Exactly. We're trying to uncover any issues that might arise when all those different pieces are working together in a real-world environment.
So it's like the final dress rehearsal before the big opening night.
It is. System testing, check everything together.
Okay, got it. So we've tested the units, the integration points, and the entire system in action. What's next on our testing journey?
Well, next we move on to a stage that's super important from the customer's perspective. Acceptance testing.
Acceptance testing. Okay, what's that all about?
This is where we make sure the software actually meets the needs and expectations of the people who'll be using it.
So it's like the final walkthrough before you buy a house.
Exactly. You want to make sure everything is in working order, that it meets your specifications, and that there are no nasty surprises lurking around the corner.
I like that analogy. So who actually conducts acceptance testing?
Usually it's a combination of the development team, testers, and actual users or stakeholders.
Oh, so it's a collaborative effort to make sure everyone's happy with the final product.
Exactly. We might have users test specific scenarios, provide feedback on the interface, or just generally play around with the software to see if it meets their needs.
And if they find any issues.
Then we go back and fix them before the software is released to the public.
Makes sense. So acceptance testing is all about making sure the software is truly ready for prime time.
Yes. Acceptance testing, does it do what the customer wants?
Another good one to remember. Okay, so we've gone through unit integration, system, and acceptance testing. Are we done yet? Is there anything else?
Well, there's one more crucial stage, and it's all about preventing those oops moments where new changes accidentally brace something that was working perfectly fine before. Regression testing.
Ah, yes, regression testing. That sounds pretty important, especially as software constantly evolves and new features are added.
It is. It's like when you remodel your kitchen, you want to make sure you haven't accidentally knocked out a wall or caused a leak in the bathroom.
Oh, definitely. You don't want to create new problems while you're trying to fix old ones.
Exactly. Regression testing is all about making sure that any changes we make, whether it's adding new features, fixing bugs, or updating the code, don't introduce new regressions.
So what does regression testing involve? Do we have to retest everything every time we make a change?
Well, ideally, yes, but in reality, that's not always feasible. So we prioritize based on the changes made.
Okay, so we focus on the areas most likely to be affected.
Exactly. We might run a subset of our existing test cases, or we might develop new ones specifically targeted at the areas that have been modified.
And if we find any regressions?
Then we fix them, of course. And then we retest to make sure the fix worked and didn't introduce any new regressions.
It sounds like a continuous cycle.
It is. Software development is an iterative process, and testing is an integral part of that cycle. It's about constantly making sure the software is stable, reliable, and meets the ever-evolving needs of its users. And remember, regression tests don't break what's already fixed.
That's a great takeaway. So we've covered a lot of ground today. From unit testing those tiny building blocks to regression testing, ensuring those changes don't cause any unexpected damage.
Right.
It's fascinating how much thought and strategy goes into this process.
It really is. And it's all about delivering high-quality software that people can rely on.
Absolutely. Now, I know there's a lot more to testing than what we've covered today.
Oh, definitely.
We've only scratched the surface.
We have.
But this has been a great foundation. I'm starting to see how those different stages of testing work together to create a robust and reliable software product.
Exactly. It's like building a house. You start with the foundation, then the walls, the roof, and all the finishing touches.
And you test each step of the way to make sure it's all structurally sound.
Exactly.
I can't wait to dive deeper into this world.
Me too.
I'm ready for more.
Let's do it.
Welcome back to our deep dive into the world of software testing.
It's great to be back.
We've been exploring all those essential stages of testing, building a strong foundation for high-quality software.
Right. From unit testing, where we look at each little piece, to system testing, where we see how everything works together.
And let's not forget acceptance testing, where we make sure the software actually does what it's supposed to do for the people who will be using it.
Absolutely. It's all about making sure the software meets those real-world needs.
Now, I want to dive a little deeper into something we touched on earlier.
Okay.
Test cases.
Yeah.
Those detailed instructions that guide our testing process.
Right, like recipes for testing.
Exactly. But how do we create really effective test cases? What makes a good test case?
That's a great question. You know, a good test case is kind of like a well-written recipe. It's clear, concise, and focused on a specific objective.
Okay, so it's not just about saying, test the login button.
Right, you need more detail than that.
We need to outline the steps, the inputs, the expected outcomes.
Exactly. It's like saying, okay, to test the login button, first enter a valid username, then enter a valid password, then click the login button. And the expected outcome is you should be successfully logged in.
Right, so we're not just checking if the button works, we're checking if it works correctly under specific conditions.
Precisely. And another key element of a good test case is that it should be repeatable.
Right.
Anyone should be able to follow those steps and get the same results no matter who's doing the testing.
Right, so it's not about one person's interpretation or experience. It's about having a consistent and objective way to evaluate the software.
Exactly.
Yeah.
And as we move through those different stages of testing, our test cases will evolve too. They'll become more complex, more comprehensive, reflecting the increasing scope of what we're testing.
Okay, I'm starting to see how those test cases really tie everything together. So let's go back to the beginning,
Okay.
unit testing. What kind of test cases would we typically create at this stage?
Well, remember, in unit testing, we're focused on those individual components, those building blocks of our software.
Right, like testing each individual light bulb before we wire them all together.
Exactly. So our test cases at this stage are very granular. They're focused on testing specific functions or methods in isolation. Think of it like this. You want to make sure that each gear in a watch is working perfectly before you assemble the whole watch.
Okay, that makes sense. Can you give me an example of a unit test case?
Sure. Imagine we have a function that calculates the total price of items in a shopping cart, including any discounts or taxes.
Okay, sounds pretty straightforward.
Well, our unit test case for this function would involve providing a variety of inputs, like different item prices, quantities, maybe some discount codes, and even different tax rates based on location.
So we're testing all those different scenarios that could affect the final price.
Right, and for each set of inputs, we would define the expected output, the correct total price. If the function's calculation doesn't match our expected output, then we know there's a bug somewhere in that function's code.
Wow, so even a seemingly simple function can have a lot of potential points of failure.
It can. And that's why unit testing is so crucial. It helps us catch those errors early on when they're much easier and cheaper to fix.
Right, like finding a crack in the foundation before you've built the whole house on top of it.
Exactly.
Okay, so we've thoroughly tested our individual units and we're confident they're working correctly.
Good.
Now let's move on to integration testing.
Right.
What does that look like in terms of test cases?
Well, now that we know our individual pieces are working, we need to make sure they can play nicely together.
Right, it's like making sure all the instruments in an orchestra are in tune and can play together harmoniously.
I like that analogy. Integration testing is all about making sure the data flows correctly between different components, that those components can communicate effectively, and that they work together seamlessly to achieve the desired functionality.
Okay, so it's about testing those connections and interactions between different parts of the software. Can you give me an example of an integration test case?
Sure. Let's say we're testing an e-commerce platform. A typical integration test case might involve a user adding an item to their cart, proceeding to checkout, entering their shipping and payment information, and then confirming their order.
So we're testing the entire flow of that process from start to finish.
Exactly. We want to make sure that the shopping cart interacts correctly with the inventory system, that the checkout process communicates securely with the payment gateway, and that the order information is accurately recorded in the database.
It sounds like integration testing is where things can get really complex and potentially messy.
They can. You're dealing with multiple components, often developed by different teams, using different technologies, and potentially even running on different servers.
I can only imagine the challenges involved in making all those pieces fit together seamlessly.
It can be tricky. But that's why integration testing is so crucial. You want to catch those integration issues early on before they turn into major headaches down the line.
Right, because fixing a problem after the software is already built and deployed can be a nightmare.
It can be a real mess. So yeah, integration testing is all about making sure those connections are solid and that everything's flowing smoothly between those different parts of the software.
Okay, so we've tested our individual units, we've checked the connections, and now we're ready to move on to the next stage of our testing journey.
All right, what's next?
System testing.
Yes, system testing, the big picture.
Welcome back to our deep dive into software testing.
Glad to be here.
We've covered so much ground already.
We have.
From those fundamental testing stages to those detailed test cases that guide our testing efforts.
Right, like recipes for success.
Exactly. And we've even touched on how to prioritize those test cases, focusing on those high-risk areas and those tricky edge cases.
Yep, got to catch those bugs early.
Absolutely. Now, I know there's a whole universe of testing techniques and approaches out there.
Oh yeah, tons.
What else can we explore?
Well, let's talk about something called black box testing.
Black box testing. Okay, that sounds intriguing.
So imagine you have this magic box,
Okay.
and you can only interact with it through its inputs and outputs.
Right.
You can't see what's happening inside, the gears turning, the code executing.
It's a mystery.
Exactly. You're just observing the external behavior.
So it's like pushing buttons and seeing what happens without knowing how it all works underneath.
You got it. That's black box testing in a nutshell.
Okay, that makes sense.
Yeah.
What are the advantages of this approach?
Well, one big advantage is that it closely mimics how users interact with software.
Mm-hmm.
They don't care about the code. They just want it to work.
Right. They just want to use the app, the website, whatever it is.
Exactly. Black box testing helps ensure that the software meets those user expectations and delivers a seamless experience, regardless of what's happening behind the scenes.
So it's all about validating that external behavior, making sure the software does what it's supposed to do from the user's perspective.
Exactly.
Okay, so black box testing is all about that external view, but I'm guessing there's a counterpart to that.
There is.
Something that does involve looking at the code and those internal workings.
Right. That's where white box testing comes in.
White box testing. Okay, so now we're peeking under the hood.
We are. It's like having X-ray vision. We can see all those intricate details of how the software is built.
So we can see the code, the algorithms, all that good stuff.
Exactly. We can analyze the code, trace those execution paths, test specific functions in isolation.
Ah, so it's a much more in-depth, code-centric approach to testing?
It is. And it's super valuable for finding certain types of bugs, like logical errors, boundary condition issues, things like that.
So when would we typically use white box testing?
Well, it's often used during unit testing and integration testing,
Okay.
when developers have that deep understanding of the code and can really target their tests effectively.
So black box is like testing if the car drives smoothly, and white box is like inspecting the engine and the transmission to make sure everything is working correctly underneath.
That's a great analogy.
Now, I've heard the term gray box testing thrown around too. Is that just a mix of black box and white box?
Pretty close. Gray box testing is kind of a hybrid approach where we have some knowledge of the internal structure, but we're still primarily focused on testing from the user's perspective.
So we might know a little bit about the code or the architecture,
Right.
but we're not diving into the nitty-gritty details of every line of code.
Exactly.
Okay, that makes sense. It's like having a blueprint of the house.
Yeah.
So we know the general layout, but we don't necessarily need to know the exact dimensions of every room.
You got it.
So we've talked about black box, white box, and gray box testing. What about the actual methods we use to execute these tests? I know we've touched on manual testing, but is there more to it than that?
There is. We also have automated testing.
Automated testing, okay. So instead of a human doing the testing, we have machines doing it for us.
Exactly. We use software tools to run those test cases automatically, simulating user actions, checking results, all that good stuff.
And what are the benefits of automated testing?
Oh, there are tons. It's super efficient, especially for those repetitive tasks.
Like regression testing, where we want to make sure those new changes didn't break anything that was working before.
Exactly. Automated testing is perfect for that. It's also great for performance testing, load testing,
Okay.
where we need to simulate lots of users accessing the software at the same time.
I can see how that would be pretty tough to do manually.
It would be a nightmare.
So yeah, automation is a huge time saver and allows us to do things that wouldn't be possible with manual testing alone. Right. It's like having a team of robots working around the clock, testing all those different scenarios.
Exactly.
But I imagine there are some limitations to automated testing too.
There are. Automated tests can be brittle, meaning they can break easily if the software changes.
Oh, right. If the code changes, the test might need to be updated too.
Exactly. And they also can't fully replace the human element of testing.
Right, because humans are still better at things like evaluating usability and those subjective aspects of the software.
You got it.
So it sounds like the best approach is to use a combination of both manual and automated testing.
It is. Each approach has its strengths, and using them together gives us that comprehensive coverage.
This has been an incredible journey.
It has.
We've explored those foundational testing stages, those detailed test cases, and now we've even ventured into the world of black box, white box, gray box, manual, and automated testing.
Right. We covered a lot.
It's amazing how much depth and complexity there is to software testing.
It is. It's an essential part of building high-quality software.
Absolutely. And to our listeners, thank you for joining us on this deep dive into the fascinating world of software testing.
Thanks for listening.
We hope you've gained some insights into the crucial role that testing plays in delivering amazing software experiences.
Yeah, happy testing, everyone.
And until next time, keep exploring, keep learning, and keep building great software.